In the 1980s, the future of medicine looked like a sci-fi dream. We had built machines that could see inside the human body and invisible beams that could burn cancer out of existence. The crown jewel of this technology was a machine called the Therac-25. It was a marvel of engineering, sleek, computerized, and fully automated. Unlike its predecessors, which relied on clunky hardware safety locks, the Therac-25 trusted its safety entirely to software. The engineers believed their code was flawless. They believed that software, unlike mechanical gears, could not break. They were wrong. Between 1985 and 1987, this machine turned on the very people it was supposed to save. Instead of delivering a precise healing dose of radiation, it quietly delivered lethal blasts of raw energy, hundreds of times stronger than a human body can survive. Patients reported seeing a flash of blinding light and feeling an intense burning sensation. The operators, looking at their screens, saw only a cryptic message, Malfunction 54. This is not just a story about a medical accident. It is the story of the most deadly race condition in history, a story of arrogance, spaghetti code, and the terrifying moment when we handed the power of life and death over to an algorithm that didn't know how to wait. The Therac-25 was designed to be a dual-mode linear accelerator. It could fire two types of beams, a low-power electron beam for surface tumors and a high-power X-ray beam for deep tissue. To generate the X-rays, the machine had to spin a heavy metal target into the path of a 25 million electron-volt beam. The beam would smash into the metal, converting its deadly energy into focused X-rays. Without that metal target in place, the raw beam would be like a concentrated lightning bolt. In previous models, physical fuses and mechanical interlocks made it impossible to fire the high-power beam unless the metal target was physically locked in place. You could try to fire it, but physics would stop you. But the designers of the Therac-25 wanted to be modern. They removed the hardware locks. They decided that software, smart, efficient, weightless code could handle the safety checks. If the sensors said the target wasn't there, the software would simply refuse to fire. It was cleaner, it was cheaper, and it was a fatal mistake. The error was buried deep in the assembly code. It wasn't a typo, it was a timing error. The software was written to handle multiple tasks at once, monitoring the keyboard, updating the screen, and setting up the beam. But the programmer had reused code from an older model without fully understanding how the new multitasking operating system worked. Here is what happened in the darkness of the treatment rooms. If a skilled operator typed the commands too quickly, specifically if they made a mistake, hit backspace, and corrected it within 8 seconds, the software would get confused. The screen would show that the machine was set to safe mode, but deep in the machine's memory, the command to fire the high-power beam had already been sent to the hardware. The software thought it was in one state, the hardware was in another. The metal target, the shield that turned the deadly beam into safe medicine, was not moved into place, but the machine fired anyway. The first known victim was a woman in Marietta, Georgia. She felt a burning sensation. The hospital staff told her it was impossible. The machine said everything was fine. She lost her breast and eventually the use of her shoulder and arm. In Tyler, Texas, a man named Ray Cox was being treated for a shoulder tumor. He felt an electric shock and heard a buzz. He screamed for help. The operator looked at the console. It showed no error, no overdose, just Malfunction 54. So she hit P to proceed. The machine blasted him again. Ray Cox died 5 months later of radiation poisoning. Still, the manufacturer, AECL, denied the machine was at fault. They said it is impossible. They claimed the software had no bugs. They blamed the operators. They blamed the patients. They believed so strongly in their code that they ignored the burns on the bodies of the victims. It took a dedicated hospital physicist, Fritz Hager, days of sleepless reverse engineering to finally recreate the bug. He had to type fast, he had to replicate the exact rhythm of a tired operator making a typo, and finally he saw it. The interlocks failed. The beam fired. The ghost in the machine was real. The Therac-25 disaster is taught in every computer science ethics class today, but its lesson is often misunderstood. It is not just about testing your code. It is about hubris. The engineers removed the mechanical safety net because they trusted their digital logic too much. They forgot that software interacts with the physical world, and the physical world does not care about your clean code. Today, we're removing the mechanical interlocks from everything. Our cars are steer-by-wire. Our planes are fly-by-wire. Our stock markets are trade-by-algorithm. We have replaced the heavy, reliable gears of the past with millions of lines of code that no single person fully understands. The Therac-25 killed 6 people, but it left us a warning written in radiation burns. When you remove the physical safeguards and leave only the code, you better be right, because the code does not know the difference between healing a patient and killing them. It only knows Malfunction 54. This was the code that killed, a race condition that turned a healer into an executioner. In the Silicon Archives, we remember Ray Cox and the others who paid the price for a few lines of bad assembly. And we ask, what safety interlocks are we removing today, assuming that our modern AI and algorithms will catch us when we fall? Subscribe to the Silicon Archives. The compilation continues.